and hi, welcome to this video of OpenFOAM. So I think last video I was going through a lot of how to navigate the OpenFOAM files. Okay, so I'm on the other laptop with I think Manjaro KDE Plasma, but the OpenFOAM is still version 2006, so not too much should change. Okay, so what are we doing here? Okay, so last time I was telling you, you got to use those functions as they are, the foam functions as they are, and so I think first thing first in this video, I just want to get you a little bit more acquainted with some of those functions. For example, the foam namespace, which I was talking about in the last video. Now, what I have done, what I want to demonstrate is this sandbox code, okay, which is able to add two scalars together, okay, and then you kind of output a file, output something. You can find the root of an equation, and of course, do a simple y equals mx plus c calculation. Where are all these things from? Okay, OpenFOAM actually has some places where they do these very simple calculations. Because as I showed you in the last video, there are lots of OpenFOAM is designed in such a way that there are a lot of functions, and each does a certain little different thing. So probably one of the functions, well, where we can start just to get ourselves a little bit more familiarized with the syntax is to consider polynomial equations. Because solving linear equations, quadratic equations, and cubic equations, those are relatively simple, and there are functions over here for them. All right, where will you find them? Okay, you will find them inside the primitive. Okay, let's see. All right, maybe I'll just show you inside the source code. Okay, you'll find them in. Okay, you'll find them in. Okay, you go to yeah. Once you're in SRC, you go cd to SRC, the source files, and then you go to OpenFOAM. Okay, this folder here, OpenFOAM. Okay, most of the stuff here, they are like the most basic functions that you need to construct your matrices, to do your meshing and everything. So to the most basic of basic, there is this folder called primitives. So go to primitives and you should see some very simple functions here. For example, you'll see places where you can have scalars, you can have tensors, vectors, those very basic things, and even to do something as simple as a polynomial equation. So that's what I'm doing today. Okay, how do we, let's say, make use of some of these functions inside OpenFOAM? Okay, so and again, I'll demonstrate the sandbox code which I just made. Okay, the sandbox code which I just made. Okay, so let me just demonstrate my sandbox code. Okay, sandbox, and let me run you through what the code looks like, and then I will start to tell you the process of how it's being made. So the sandbox code is very simple. It adds two scalars, it finds the root of an equation, and it does some simple y equals mx plus c kind of thing. Okay, how did I do this? Okay, if you take a look at the sandbox, let's go sandbox.c. Okay, and then there will be a certain template that you get. I include this linear equation.h. Where does it come from? You go to linear equation, you will see this thing called linear equation.h. This is where I include the linear equation stuff for all the, what do you call it? Yeah, for all the functions that I'm going to use. Okay, then there'll be ways. Remember fvCFD.H, that's a very important include also, because it gives us the foam namespace and most of the tools that we need to start using some of the OpenFOAM functions. For example, if you want to declare a scalar, this is not normally present in C++. So this actually uses the foam namespace. Okay, scalar A, scalar B. Then you have this info thing here. What is info? I'll let you know shortly, but actually, yeah, I can just tell you now. Info is basically just a way for us to print stuff. So just like we have cout. Okay, we have cout in our standard namespace. Okay. We have cout in our standard namespace. Standard cout hi. And line here. It is the same as foam hi. It's the same thing. And you notice that the end line over here, you can use standard or you can use foam. Both will do okay. So let's try compiling. Okay, this is using wmake, and I'll let you know shortly how I get all of this. Okay. So right, okay. I think my foam namespace has not been declared. Okay. Let me check fvCFD.H. Maybe I did a misspelling. Oh yes, indeed it was a misspelling. Okay, so this is the API guide. So I just fast forward you to this part. It says using namespace foam. Foam is supposed to be a capital letter, not a small undercaps letter or small letter. Okay. So let's clear everything. Go to sandbox.c. Let's use the proper namespace. Not small letter foam, but big letter foam. Now we should be able to compile. And of course, the compiler will complain if there's anything wrong. So let's see. Let's do sandbox. You see, both of these codes actually say hi. Okay, so that's one part of it. The fvCFD.H, that's the namespace bit. There are a few includes here which I kind of commented out because we are not using them. Okay, so these are very basic things. Linear equation, blah blah blah. A linear equation was defined here, and this is one of OpenFOAM's many functions that are being defined. I use this example because it is pretty trivial. Okay, pretty trivial. And then you can see some of these functions here, some constructors. Okay, I'm a bit rusty. Yeah, yeah. I think I'll probably need to. Okay, yeah. This thing I'll probably need to, constructors are some functions that you begin yourself. You initialize the function, so to speak. And then there are member functions. For example, there are scalar A and B, blah blah blah. And then you have functions that help you evaluate. And of course, there's this inline thing over here as well. Okay. What is inline? Okay, inline is a way you can use to execute your functions a little bit more efficiently. You compile your code. But that's really oversimplifying a lot of things. Okay, there is a very much something that's more in depth. You can look for inline functions in C++, or you can look for some videos on YouTube. I'll put these in the description if you really want to know what inline is. But it's basically one way of executing functions that may or may not increase your execution time. So it's just an efficiency tweak. Okay, one more acknowledgement before I start. One more acknowledgement before I start. I think there's a very good YouTube video called OpenFOAM Programming Course by, looks like Tom Smith from UCL. He shared his Dropbox, which gives some example codes of how to use program in OpenFOAM. I think you should go and check it out. I mean, I learned some bits from him as well. But without further ado, let me show you how I use some of these functions inside OpenFOAM. Okay, the bash. Okay. All right. So let's run through how we got to this point of code. Just demonstrate. Okay. So this will be in my OpenFOAM C YouTube what do you call it, Git folder. If you go to this place I call Foam Sandbox, okay, Foam Sandbox is just a place, you know, we can play with OpenFOAM functions. That's why I call it sandbox. If you go to foam namespace, this is where I test the foam namespace. Yeah. So how do we start? Okay, how do we start? Let me start by using, okay, let's do touch make new app. Okay. So chmod 755 make new app. I hope you know what this does. This is actually making this bash script executable. So let's vim make new app. This is some bash coding that I'm doing. And this is yeah, I have a video series on OpenFOAM Bash, so do take a look at it. But it won't require that much knowledge. Okay. So I'm just going to record the lines I use in the bash script here. So first thing we do is something called foamNewApp. This is one of OpenFOAM's ways to get us, you know, what do you call that? Yeah, this is one of OpenFOAM's ways to help us, you know, create new applications. Okay. Yeah, so it's there to these scripts are there to help us to get new applications, and one of these scripts is called foamNewApp. So if you install OpenFOAM properly, you can use this thing called foamNewApp. What does it do? Okay, it's like so. It creates a directory with source and compilation files for a new application. Okay, why do we want to do it this way? Because I know in C++ normally we manually want to make our own make files and everything. And that's the way if you really want to learn all the underworkings. You want to know what everything, all of these make files do. But OpenFOAM already has a way to make the relevant make files and start us with a int main kind of a C++ file or C file. Okay, so what you need, all you need to do to use this is to use foamNewApp. I believe yeah, this is ESI version. I think the OpenFOAM Foundation version should work with this as well. But yeah, this is the ESI version 2006. Okay, so what our foamNewApp be? I'll just call it sandbox 2. Okay. So once you make this app, you can go to sandbox 2. cd sandbox 2. And then you'll see, okay, there's a sandbox2.c file, and there are make files and options. Okay, so if you do a cat star, you will see the following. Okay, inside the first files options, you'll see the code to compile is this sandbox2.c. The executable will be dumped into the foam user app bin, okay, under sandbox2. So that's the executable file. The options, okay. The nice thing about this is that you already have all your include sim links there from finite volume and mesh tools, and the executable libraries are also from finite volume and mesh tools. Now, if you don't feel this is enough, you can of course copy some of the includes from the other solvers, but this is a very basic thing just to get you acquainted. You don't want to give it too much information at this point in time. All right, so let's take a look at the sandbox2 C file. What you will see is this. You will see this standard OpenFOAM line. You will see this copyright blah blah blah. You can put your name here. You can put what company or wherever you're from. Then you see this license over here. Then the application is called sandbox2. Okay, description, you know, fill it in yourself. Okay, it's always good to have comments. then usually what you start with is include fvCFD.H. Okay, so we always like to start with that because these are used in almost every single foam file. Now, there's a set root case and create time.h. Okay, set root case and create time.h. This we will not use just yet. Okay, this we will not use just yet. So we'll just limit the number of includes that we have. And of course, all of this info, N1, and all this I'm going to take up. Okay. So let's start again with something very simple. Before I do anything, I actually want to change my options. No, change my files in the make folder. I want to change it to I don't want to dump it in the foam user app bin because I want to be able to. I don't want to clutter my foam user app bin with so many random apps because this is a sandbox thing. I'm going to iterate many times. Okay. So I'm going to have my executable inside this directory here, where I have my sandbox2.c. I want my sandbox2 binary to be over here. Okay, so let's say I just have a very simple file like this, include fvCFD.H. Then I just have the int main return a 0. It's not a code that's doing much, but it will run. So to compile, instead of using G++ or GCC, we just use wmake. Very simple. Okay, so this is, if it runs correctly, then OpenFOAM will give you this. I mean, the wmake will give you this output. If you do sandbox2, nothing will happen because we did not make sandbox2 print or do anything. So to clean this up, you can use wclean, but sandbox2 will be there. So I can just remove sandbox2. That'll be done. And that's the reason I want to keep my binary files here so I can clean and remove anytime. I don't want to over clutter my space. Okay, so let's go to sandbox2 C, and first thing first, let's put what we learned, what we just go into practice. Okay, the info. Okay, because this info is under the namespace form. Okay, it's usually under the namespace form, and we can just use this as a print, as a printing function. So same as C++, make sure you always have your semicolons at the back. Okay, so I'm just going to print two lines of code. Okay, this is the first line is of course if you really want to specify the namespace that you are using, meaning I'm using the namespace form. I want to have info. I want to use the namespace form. I want to have inline. So since this, if you really want to specify which namespace you are using, otherwise you can just use info because including fvCFD.H, it will help us to already have this foam namespace. So let's see. I am using the foam namespace. Okay, so this is what we can do. Okay, and then we can just compile wmake. Okay, it will take a while because we are linking a lot of libraries. Remember. Okay, sandbox2. Okay, so I say hi. I'm using the OpenFOAM namespace. Now let's go next and let's do some mathematical additions. Sorry. See how much time we have left. Okay, it's about 19 minutes in. Oh boy. Okay, let's do some math before we call this day. Sandbox2.c. Okay, next thing we can do is to start declaring variables. For example, I mean in C++ you can declare integer and float. In OpenFOAM, instead of declaring integer and floats or doubles, we can just do scalar straight away. Okay, so the first scalar I can do is 5.42, 4.23. Okay, A equals to 5.42, B equals to 4.23. Okay, I forgot my semicolon there. And what can I do? I want an info. I want to print it out, right? I put A equals to A, and I put space semicolon B equals to, and I'll just do B, and then I'll have an inline there. Okay, so things should be okay. I should be able to make again. Okay, and if I run it, I will see that A equals to 2, B equals 4.23. Okay, so these are basic scalars that we can do. Now we can do some scalar math as well. Very easy. And I mean, you can, of course, yeah, you can do scalar math with scalars. So the next one is just what? A multiply inline, multiply A and B, inline. Maybe I'll just put here A times B. Okay, info. Then let's do if add A and B. I'm not going to do all 4 of them. Okay, A plus B. And line there. Of course, if you want, you can use brackets as well. A plus 1. I'm going to do divide A and B. A by B. Then I'll just do a bracket A slash B. And okay, so let's go double make. A very simple OpenFOAM math. Okay. Right. So there's an error. Let's see how we can rectify this error. Okay. Let's see how we can rectify this error. Or maybe I just remove the brackets. I think C++ is just touchy with brackets. Now let's see whether removing the brackets will help. Okay, okay. So it's an invalid operand. Okay. Oh, hang on there. I think I see the error. There's only one error over here. That's such a silly mistake. Okay, let me try again. Sandbox2.c. Let's do the A divided by B. And let's put in our brackets. Okay, just so you know there is such a thing. We can actually use brackets. Now let's double make again. And it works right. Let's do sandbox 2. Okay, so add A and B, which is about 9.65. Multiply, you should get this much. Divide, you should get this much. Okay, so this very basic stuff. I'm not going to do too much. Okay, not going to do too much here. But at least this shows you, you can use OpenFOAM libraries very easily to do some basic math. So you don't have to, do your double floats and everything all over again. But you just use the OpenFOAM namespace. Should be quite that much easier to do a bit of that math, just like we do in C++. Nothing too different there. Okay, so this video actually shows you about some of the OpenFOAM namespace and how we can use it to do math. But next time, let's actually do the linear equations. So I'll stop now. I'll see you again.